Hello, my amazing Year 8 students. Welcome back. Thanks for the following all the given directions and coming here to meet me in our next session. As you may recall, in earlier classes, you learned about simultaneous equations and how to use different techniques to solve them. Please note that today's discussion area is very similar. However, it will require us to use the knowledge about quadratics as well. In other words, today we will focus on quadratic simultaneous equations. Please prepare all necessary tools, including a calculator, which is an inseparable part of this lecture. So, if everything is clear, first let's check what we will learn today and then start the explanation. Let's begin. Firstly, we will discuss what are quadratic simultaneous equations and which properties they have, and then we will learn how to solve quadratic simultaneous equations, and of course we will solve different questions to ensure your better understanding about this topic. Firstly, let's start with the meaning of quadratic simultaneous equations. Quadratic simultaneous equations are two or more equations which share variables that are raised to the power 2. For example, x squared or y squared. Look at the following examples. In these examples are quadratic simultaneous equations, and they consist of one linear, one quadratic equation. For example, y equals x plus 3 and y equals x squared plus 5x minus 2. As you see, in the first equation, the power is 1, which means it is a linear equation. But in the second one, we have x squared. As a result, we can say that the second equation is quadratic. It is the same for the second example. Y squared plus x squared equals 29 and x plus 7 equals 5. As you see, in the first equation, we have x squared plus y squared, which means it is a quadratic equation. But in the second one, we have only x and y, and their powers is 1, and it shows us the second equation is linear. One key difference of quadratic simultaneous equation is that we can get multiple answers here. This is because of the way the graphs of linear and quadratic functions can intersect. Please consider that these graphs and these functions will be discussed in our next lessons. Now let's learn how can we solve quadratic simultaneous equations. If we want to solve them, we should follow the next steps. Firstly, eliminate one of the variables and then find the value of another variable. In the third step, you should find the value of the remaining value. If you want to find the value of remaining variable, you should take the answer which you found in the step 2 and you will substitute it in the given equations. And then clearly state the final answer or answers. As a final step, you can check your answers by substituting both values into original equations, just to be sure that your answers are definitely accurate. Firstly, let's try to solve the given quadratic simultaneous equations. Here we have y equals x plus 3 and y equals x squared plus 5x minus 2. As you see, the first equation is linear, however, the second equation is a quadratic. So firstly, we can take this y equals x plus 3 and we can plug it in the second equation instead of y. So it will be x plus 3 equals x squared plus 5x minus 2. And then if we want to solve this quadratic equation, we will write all terms on one side. So it will be x squared plus 5x minus x minus 2 minus 3 equals 0. X squared plus 4x minus 5 equals 0. Now, if we want to solve it, we can use different methods, such as completing the square, discriminant, or factorization, or vieta. Doesn't matter which one is comfortable for you, you can use this method. For example, I mostly prefer to use factorization. Let's check. M plus n equals 4, and mn will be negative 5. And if we want to find m and n, for example, we can plug negative 1 and 5 instead of m and n, because the sum of them will be 4 and the product of them will be negative 5. So let's write x minus 1 multiplied by x plus 5 equals 0. If we want to find both x one by one, we will write x minus 1 equals 0, x equals 1, and x plus 5 equals 0, x equals negative 5. As you see here, we found 2x, but this is not the final answer because here we have two variables, x and y. So which means after finding x, we should find y as well. For this reason, we will take each value of x and we will plug it in the first linear equation. So if x is 1, let's write x1 for this, y1 will be 1 plus 3 equals 4. Or if x2 equals negative 5, y2 will be negative 5 plus 3 equals negative 2. So let's write the final answer. x1 equals 1, y2 equals 4, and x2 equals negative 5, y2 equals negative 4. As you see here, we found 4 answers, 2x and 2y. In the second quadratic simultaneous equations, we have x plus y equals 4. If you want to eliminate one of them or if you substitute one of them, firstly, let's rearrange the equation. So we can write, for example, y equals 4 minus x. And then you can take 4 minus x and plug into second equation instead of y. So we will write 4 minus x equals x squared plus 3x minus 1. As a previous question, firstly we will write all terms on one side and then we will try to find the values of x. So it will be x squared plus 3x plus x minus 1 minus 4 equals 0. X squared plus 4x minus 5 equals 0. It is the same with the previous question, so let's write it directly. We will get x minus 1, x plus 5 equals 0, and x1 will be 1 and x2 will be negative 5. So as I mentioned before, this is not the final because firstly we should find y2. So take this 1 or negative 5 and plug into linear equation. So we will get y1 equals 4 minus 1 equals 3, y2 equals, we will write 4 minus negative 5 equals 9. So if you want to write the final answers, we will write x1 equals 1, y1 equals 3, and x2 equals negative 5, y2 equals 9. For the first time, you can think that both of the equations are linear because in both of them, the highest degree is 1. But if you make substitution in one of these equations, you will get quadratic equations as well. So firstly, let's choose in which one we will rearrange the equation. Firstly, let's take the first one. In this case, we can write x equals 12 over y. But here we got fraction. But as I mentioned before, we always try not to get fractions for easier calculations. For this reason, it would be better if you use the second equation to rearrange. So for example, you can write y equals 3x minus 9. As you see, here we got linear and all of the coefficients are whole numbers. So let's take this y and plug into first equation. It will be x multiply 3x minus 9 equals 12. 3x squared minus 9x minus 12 equals 0. As you see here, the coefficient of x squared is 3, but 3 is a common factor for all these terms. And remember that if we have equation, we can divide all terms by the same number. So let's divide everything by 3. It will be x squared minus 3x minus 4 equals 0. Now let's apply the rule about factorization. M plus n equals negative 3 and mn equals negative 4. We can use negative 4 and positive 1 instead of m and n. So let's write this form. X minus 4 multiplied by x plus 1 equals 0. If we want to find x, we will write x minus 4 equals 0 and x equals 4 and x plus 1 equals 0, x equals negative 1. So x is ready. Now it's time to find the values of y as well. If you want to find y, you can take these values and plug into first equation. So first let's start with 4. If x1 is 4, y1 will be 3. And if x2 is negative 1, y2 will be negative 2. So as we did in the previous questions, in this question we got 4 answers as well. Discriminant equals b squared minus 4ac equals b is negative 28 here, so it will be negative 28 squared minus 4 times 5 times 15. It will be 484. Of course, you can use a calculator to find this discriminant. And then let's try to find x. We can write that x equals negative b plus minus root of discriminant over 2a. Let's plug the numbers. Negative b is negative 28 as well. If we add one more negative, 2 negative will give positive. So it will be 28 plus minus root of 484 will be 22 because 484 is 22 squared. Let's write directly plus minus 22 over 2a, and we know that a is 5. 2a will be 10. So let's write x1. For x1, let's use plus. It will be 28 plus 22, which is 50, over 10 equals 5. And do the same thing for x2. But in x2, we will use subtraction. It will be 28 minus 22, which is 6, over 10. It will be 0.6. After finding x, the next step is finding y. For this reason, you can take the values of x and plug here. If you plug here, y1 will be 2 times 5 minus 7, which is 3. And if we want to find y2, we will plug 0.6 instead of this x. It will be 2 multiplied by 0.6 minus 7 equals 1.2 minus 7 equals negative 5.8. In the final question, x is given. X is 2y. But in the second equation, which is quadratic, you have 2x. Here we have x squared and plus xy. It doesn't matter how many x you have. It can be 2, 3, 4. You will substitute all of them, which means you will take this 2y and you will plug it 2 times. Firstly here instead of x squared, and secondly here into xy. So it will be 2y squared minus y squared plus, again plug it one more time instead of x. It will be 2y multiplied by y equals 20. 4y squared minus y squared plus 2y squared equals 20. 4 minus 1 plus 2 will be 5y squared equals 20. Y squared equals 4, and we can write that y1 equals 2, y2 equals negative 2, because we know that 2 squared is 4, negative 2 squared is positive 4 as well. So y is ready. Now it's time to find the values of x. We will do the same thing. Firstly, we will take this y and plug into first equation to find x. For example, if y1 equals 2, x1 will be 4. Or if y2 equals negative 2, x2 will be negative 4. So one of the answers is 2, 4. Another one is negative 2, negative 4. That is the end of today's lecture. Today we talked about the meaning of quadratic simultaneous equations and how can we solve them. I believe all explained examples and material were clear and beneficial for you. Please keep in mind that the key to this topic is studying the mentioned technique and applying it to the provided questions. For better outcomes, please practice with a calculator to use it properly and complete as many practice questions as you can. I'm absolutely sure you will do your best to make me proud. I wish you success in all your missions. Goodbye to all of you till our next lesson. See you!